there's plenty of decay going on in the core, and so the core is extremely hot. Interestingly, the geophysicists tell us that the inner core is solid and the outer core is liquid. Liquid is very different physically than solid. The outer core, this liquid outer core, is really hot, and it's much hotter than the mantle just above it. So the boundary between the outer core and the lower mantle is extremely different in temperature. And it's more than 1,000 degrees centigrade difference. That means it's not terribly stable. So others will tell you about plumes, but plumes are a reflection of the cooling and this discontinuity between the really high temperatures in the core and the much lower temperatures in the lower mantle. But the point I wanted to make, as someone who thinks about petrology, igneous rocks, is that this discontinuity sets up the start of a plume, so that the hot, viscous mantle just above that discontinuity between the outer core and the lower mantle, it sets up a bunch of material that slowly rises, and it's not molten, it's solid material that's quite gooey. So it rises, and as it rises and gets to lower and lower pressures, it starts to melt incrementally. Melts, 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 and it's only towards the very, very top that we see a molten material, which then can come out with massive flows of salt onto the continents and ocean floors. So that's a reflection of the cooling of the Earth and this incredible thermal energy that we started with, and a whole bunch of radioactivity driving all of this and keeping this hot, so that it's still extremely hot down there. So now, this is part of the convective mantle. And they calculate, they make estimates that it takes 200 million years to entirely overturn the mantle, which means it's mixing. And if you think about it, over 4.5 billion years, it's been mixed thoroughly a number of times. But that doesn't mean it's all the same and there aren't changes. So that as we go down into the Earth, we realized some years ago that there is a reflector at 660 kilometers, which was first identified by a Russian called Mavrogenes. So of course we call it the Moho. And this is a transition from one mineral phase to another due to pressure.